Unit 8, Chemical Bonding, pages 191 to 196, and this is focusing on resonance. Resonance. Ozone, or O3, has these two equivalent Lewis structures. Notice that there's a double bond and a single bond, and then a lone pair at the top. The double bond could either go here between the middle oxygen and the one on the right, or the double bond could go between the middle oxygen and the oxygen on the left. A double-headed arrow is used to indicate resonance, meaning the structure is actually both of these simultaneously because that double bond is actually moving between these two locations constantly. These are called resonant structures. The arrangement of electrons is similar in both structures except that electrons are shifted to different atoms. The only difference between resonant structures is the position of the electrons. The atoms cannot be moved. Resonance hybrid. The significance of resonance is that the actual molecule will not look like any of the individual resonant structures. Instead, the actual molecule will be an average of the resonant structures and is called a resonance hybrid. So instead of a double bond here or a double bond here, we're actually going to have a hybrid between the two. The dashed line represents a 2-electron bond that spans all 3 oxygen atoms. The actual bonds in ozone are both identical and in between a single and a double bond. This would be how you will see a lot of the questions asked when discussing resonance. And this would be an answer that you want to look for. Identical bonds in between a single and a double. Resonance in benzene. Benzene has the molecular formula C6H6. The carbon atoms form a ring structure with alternating single bonds. These are resonant structures. The benzene ring is usually stable because of the existence of the resonance. So notice you have your double bonds in every other carbon here, and then instead they could be in this location, and this location, which is depicted here. But benzene resonance hybrid, the actual bonds in the ring of benzene are all the same. The bonds are in between single and double bonds. So we tend to draw benzene like this, or with the little dotted line, to show that your double bonds are equal across, the bonds are equal across all of these. The molecular structure of benzene is often drawn with a circle in the ring to represent 6 electrons that form a bond which spans the entire ring. Another way to imagine resonance in benzene is to picture the molecule hopping back and forth between the 2 resonant structures connected by the double-sided arrow symbol above. Although this is not an accurate picture, it does provide a way to see why the bonds in the ring are actually in between a single and a double bond. Exercise 8.47. Draw the Lewis structure for SO3 and determine if the molecule has resonance and guess what the resonance hybrid looks like. So we have SO3 and we have 6 plus 6 times 3, which is going to equal 24 electrons. And so we have sulfur in the center, oxygen on either side, so 3 oxygens total. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now I have my total valence, but notice we do not have an octet on the sulfur, which means that this pair of electrons actually acts as a double bond between the sulfur and the oxygen. So now I could have my double bond here, or I could have the double bond in the other location. So these are the 3 different places that you could have this double bond. So what would the resonance hybrid look like? Well, we would have the sulfur with the 3 oxygens, and then we would say that we could have our electrons here and here and here. So basically in all 3 of the locations you have a little bit. So because we could have 3 possible resonance hybrids, then you can say that each of these locations is 1 1/3 bonds, and you have your bonds are between a single and a double. So this molecule has 24 total valence electrons. After drawing the arrangement of the atoms and putting the valence electrons on the outside atoms, we obtain this structure here. There are no valence electrons left, so non-bonding electrons must be converted to a double bond to give the central sulfur an octet. Notice that there are 3 possible places where the double bond can be positioned, and this would lead to having resonance structures. So the resonance hybrid would be a mixture of these three resonance structures. All of the bonds will be the same and will be in between a single and a double. And here they just did a dotted line each location where you could possibly have the double bond. The actual SO3 molecule is an average of all of the resonance structures and includes a small contribution from these two resonance structures. Additional resonance structures. Since sulfur is allowed to exhibit an expanded octet, have more than 8 electrons, the following resonance structures are also possible. So you could have these two double bonds, or you could have all three of these double bonds. According to the rules for drawing Lewis structures, these are perfectly valid structures. A quantum mechanical calculation must be done in order to figure out how important a particular resonance structure will be. This is for professionals. The two structures shown above have lower overall formal charges. However, a general rule is that resonance structures that require the central atom to violate the octet are of lesser importance. Here's your note card for this section. Resonance occurs when there is a double or triple bond present. When the Lewis structure can be drawn multiple ways, there is resonance. The resonance structure bonds are typically said to be between a single and a double bond, represented with dotted lines, or called a resonance hybrid. Two resonance structures would have dotted lines, and therefore the dotted lines would each be 1½ bonds.